Hi everyone, in this video I am going to go through all the answers for the z-scores worksheet. Okay, in scenario 1 you're told that you have a midterm where the mean was 30 and the standard deviation was 6. And we are to assume that the exam scores are normally distributed. Next, you are given a series of percentages and you're asked to find the corresponding z-scores and raw scores. So you should be able to go between percent, z-score, raw score, starting with any one of those and getting any of the other ones. Okay, so I'm going to start by drawing a distribution. Okay. It doesn't have to be pretty, right? It's just to help you keep track of all the pieces. Okay. So, we're told that the mean is 30. So I'm going to use blue for raw scores. Okay. So raw score is going to be blue, and then I'm going to use red for z-scores. Okay. So the mean of the z-distribution is always 0. Okay, so if 50% of the class scored better than me, then we know that z equals 0, right? Because you have half of the distribution above the mean and half of the distribution below the mean. Okay, if 2% of the class scored worse than me, so in there is 2%. Let's go over to our z table. So what we're looking for is the percent in tail that is closest to 2%. So here we go. So percent in tail, closest one is 2.02, and that gives us a z-score of 2.05. Because we're on the negative side of the distribution, that gives us a z-score of minus, z equals minus 2.05. Okay, and that's right here. Can't really see that. Oh well. Okay. Next, 16% of the class scored better than me. Okay. So we've got 16% in that tail. Okay. So back over to our table, we are looking for the value with percent in tail closest to 16%. Okay. So this one right here. So we've got z equals 0.99. Now this is a positive score because we are on the positive side of the z distribution. Okay, now we need to find the corresponding raw score. I'm just going to type directly in here. So we said raw scores are blue. Okay, so to get our raw score, we have our regular equation z equals x minus m divided by, I'm going to write out sigma. I don't have that character readily available. Okay, so if we've got 0 equals x minus, our mean was 30, and we are dividing by 6, we can rearrange this multiply both sides by 6, we've still got 0 equals x minus 30, so we know that x has to equal 30. Now, we actually didn't have to do the math for this one. We already have it right here, right? X equals 30, because that is the mean of the distribution. Okay, so let's actually switch this into a general form equation where we solve for x. Okay, so if we've got z equals x minus m divided by sigma, we have z times sigma equals x minus m. So then we get z times sigma plus m equals x, and flip it around just so that we've got x on the left. So taking this equation and putting it over here, we've got x equals minus 2.05 times our standard deviation, which was 6, plus the mean, which was 30. Okay, I'm going to copy this, paste it in here, and we've got our answer of 17.7. Okay. So we can take that same equation and we're switching out our z-score. Here we've got a z-score of 0.99. Going over to our calculator, I can just replace that z-value, and we've got our answer of 35.94. Okay. Find the percentage of scores that, that fall between these z-scores and the range of raw scores they correspond to. Okay. Okay, so I'm starting with z-scores because that's what we have in the problem. As you can see, these are all whole numbers, so I'm just going to draw those on there. 1, 2, minus 1, and minus 2. Okay. So find the percentage of scores that fall between these z-scores. So first we're asked for between 0 and 2. So that is this region. Okay. So to do this, we go over to our table and we find a z-score of 2. A z-score of 2. And this is the percent in the tail. This is the percent between that cutoff and the mean. So this is the part we want. So here we've got 40, 47.72. Okay. So next we've got between minus 1 and 0. So that's this space right here. Okay. So the z-table doesn't have any negative numbers, it only has positive numbers, but because it's symmetrical, this space right here is going to be the same as this space right here. So we look for a z-score of 1. Okay, so we've got a z-score of 1, and we are asked for between 1 and the mean, so that is 34.13. Okay. Now we are asked for the space between -2 and +1. So that is this whole space. Because we said that the distribution is symmetrical, the amount between 0 and +2, which was right here, is the same as the amount between 0 and -2. So we can do 47.72 to give us this area right there. And then the distance between 0 and 1 is the same as the difference between 0 and -1, again because this is symmetrical. So we've got 34.13. Okay, 47.72 plus 34.13 gives us 81.85. Okay, next we're asked to find the range of raw scores that they correspond to. So we said that our mean is 30 and the standard deviation is 6. So if we're moving up one standard deviation, that one's going to be 36. We move up another standard deviation, that one is 42. Okay, so here we're moving down one standard deviation, so 30 minus 6 is 24, minus another 6 is 18. Okay, so if we are asked for the raw score that corresponds to 0 and +2, we've got 30 and 42 as our range. Okay, minus 1 is 24 and 30. And then we've got minus 2, which is 18, and plus 1, which is 36. Okay, those are our ranges. Okay, scenario 2. We've got a machine that fills bottles with vinegar. Standard deviation of 8. Sample size of 100. Mean volume of 356.5. Find the 95% confidence interval for the mean volume of vinegar in samples of 100 bottles. Okay, so our confidence interval equation, we've got mean plus minus z times sigma sub m and we've got sigma sub m, so that's the standard deviation of the distribution of means, equals sigma divided by square root n. Okay, so that's this one right here. Okay, so going to take this and plug in our mean of 356.5. And for sigma sub m, we can take this and substitute it in. Okay, sigma is the standard deviation, and we were given standard deviation of 8, and we have a sample size of 100. Okay. So square root of 100 we can simplify. That one's pretty easy. And 8 divided by 10 is also pretty easy, so we can simplify that further. Okay, now we need z. Okay. For the 95% confidence interval, you have 95% in the middle, which means 5% in the ends, so that's 2.5% in each end, in each tail. Okay, so percent in tail, let's look for 2.5. Oh, there we go. Here is 2.5, and that is with 1.96. So over here, we've got 1.96 and minus 1.96 as our cutoff scores. Okay, so 1.96. Now, because this is always going to be the same, 1.96 is a number you should probably just memorize because 95% confidence intervals are very common. Okay, I'm going to copy this, go over to my calculator, paste it in. It doesn't understand my plus minus, so I'm going to start with minus because that gives us the lower end of our confidence interval, 354.9. And then I can just highlight this, change it to a plus, and now I've got 358.1. Okay, there is our 95% confidence interval. Okay. For each of the following volumes, calculate the z-score, determine whether it falls within the 95% confidence interval, and if I were to grab a bottle of vinegar off the production line at random, what is the probability that the volume it contains is more extreme than this volume? Okay. So, these z-scores of plus and minus 1.96 correspond to this confidence interval of 354.9 and 358.1. Okay, so next we have 3 raw scores, and we need to convert them to z-scores, determine whether they fall within the confidence interval, and determine the probability of getting a volume that is more extreme than the given volume. Okay, so looking at 353.7, we can see that it is outside of this range, right? 353 would be over here. So this is outside. 358 is between these two values, so it's inside. And 355 would be just barely inside, right? Okay. So we're supposed to find the z-scores. So if we have the general equation of z equals x minus m divided by the standard deviation of the distribution of means, so that is sigma divided by square root n. So sigma is 8, and we are dividing by square root of our n, which was 100. Now we can simplify this. Square root of 100 is 10. That's pretty easy. And 8 divided by 10 is 0.8. So that's nice and simplified. Okay. And the mean is 356.5. Okay, here is our general equation. I'm going to copy and paste that for each of these, so I don't have to retype it every time. Okay, and here our x is 353.7. Here we've got an x of 358, and our raw square 355. Okay. So I'm going to copy this, paste it in my calculator, and I get a z-score of negative 3.5. Okay. Now this z-score makes sense because negative 3.5 is more extreme than negative 1.96, and we said that this one is outside of the confidence interval. So for the raw scores, we're looking at blue. It's outside these two values. For the z-scores, we're looking at black. It's outside those two values. Okay. Next one. So I can just come over here and change this directly. So we've got 358. Everything else stays the same. .875. Okay. This one also makes sense because 1.875 is between these two values. Alright, and over here, last one, we've got 355. Oh, and that gives us minus 1.875. Okay, so these two values are equidistant from the mean. It's just that one is below and one is above. Okay, so this is part A, this is part B, and for part C, we are asked, if I were to pull a bottle at random, what is the probability of getting a volume that is more extreme than the volume we were given? So to do this, we need our z table. Okay, and now we're looking for a z of 3.5. Remember that the z distribution table is only positive numbers, but that's fine because the distribution is symmetrical about the mean. We only need the positive numbers. So minus 3.5, 3.5. Okay, so we are asked for the probability of getting a score more extreme. So that would be out here. Because this is a symmetrical distribution, this area is the same as this area. And this is the one that's going to be on the table because we only have those positive numbers. Okay, so look for a z-score of 3.5. Z-score of 3.5, and we're told that there's 0.02% in the tail. .02%, or if we wanted to write this as a whole number, or not a whole number, but a decimal instead of a percent, that would be 0.0002. Okay. So here we have a z-score of 1.875. We want to know probability of getting a score more extreme. So we look for 1.875. So we'd have to round that to 1.88, and that gives us 3.01%. Which is the same as 0.0301. Okay, and here we have the same z-score, but on the other side. Right, so negative 1.875. The distribution is symmetrical, so we know right away that we get the same answer for C. And we're done.